Hello everybody. Today we're going to be taking a look at projectile motion. Now, what is projectile motion? Well, maybe something that you're already familiar with, but let's take this situation where we have a hamster. Now, if we want to kick this hamster as far as we possibly can, we have to give it some initial velocity, maybe with our foot or with a slingshot or something, okay? So that hamster is going to have an initial velocity, and it's going to follow this arcing motion, a parabolic trajectory, okay? Now, as we know, from 2D motion that any velocity has an x and a y component. So whatever angle you kick that hamster at, it's going to have an x velocity and it's going to have a y velocity. Now, projectile motion answers the question, what is the position of this hamster at any given time along its trajectory? That is to say, when you kick this hamster, when it's flying through the air, it's going to have some x position and it's going to have some y position. Now, you may be familiar with some strategies with solving projectile motion already, but what I want you to do is I want you to kind of think of projectile motion as a 2D motion problem. A 2D motion problem will have the equations Vx is equal to the initial velocity plus the acceleration of the x times time, and the x position is going to equal the initial x position plus the initial x velocity times time plus 1/2 the acceleration in x direction times t squared. Now, this is a special situation of a 2D motion problem. So let's see how these 2D motion equations change during projectile motion. Now, the thing about projectile motion is there's no forces acting on that hamster in the x direction. If there's no x directional forces, that means there's no x directional acceleration. So this ax term goes to 0 meters per second squared because there's no forces. This one down here is also going to go to 0 meters per second squared. So how can we rewrite these equations? Well, we can rewrite them as Vx is equal to V0x. There's constant speed or there's constant velocity in the x direction throughout the trajectory. The x position, well, now that's just going to be given by x is equal to x0 plus V0x times t. There's no acceleration term. Great, that's in the x direction. But what about the y direction? How is that going to change? Well, we know that there's going to be an acceleration in the y because there's a force acting on this hamster in the y direction. What's that force? That force is the downwards force of gravity, okay, mg. The acceleration in this term is g. G is equal to 9.8 meters per second squared. But you might ask yourself, what's the direction? The direction is down. And a downward direction means that there's going to be a minus sign, okay? G is not negative. The direction is negative, okay? So how can we change these equations over here? We now have Vy is equal to V0y minus G times the time. Remember, the minus sign comes from the downward direction. And this position equation down here, the y position is going to be the starting position plus the initial y velocity times time minus g divided by 2 times t squared. Now, there are some situations where you have information with this equation right here, and you're looking for the time. Now, the time has this t squared term, and it can often have this t term as well. In this situation, when you're looking for the time, okay, what you want to be doing is you want to be looking towards this quadratic equation up here. You may remember this from one of your math courses, or you might remember as a meme on the internet. The quadratic equation states that given a quadratic, ax squared plus bx plus c equals 0, you can solve for x by using this equation here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is going to give you two answers, so you have to be able to interpret those answers. And this x does not mean the x position. This is just a variable, okay? In our case, this x is going to be that t, okay? So whenever you're solving a problem, that's going to be t. So let's take a look at a question here. Let's read it. A cannon at a sporting event launches a t-shirt from the field at ground level into the stands. If the cannon launches the projectile with a velocity of 18.7 meters per second forward 55 degrees up, and the operator wants the t-shirt to land in the stands 11 meters above the ground, how far away horizontally should it be placed? That is, what is this distance here? How far away should this cannon be from where it lands in the stands? What information are we given? Well, we're given that the initial velocity is 18.7 meters per second, forward 55 degrees up. This means that it's going to be launched at an angle, which means it's going to have some initial x velocity, and it's going to have some initial y velocity. Let's do the calculation on those and put them right into the given section really quick, because we know we're going to need those later on in the problem. So the initial x velocity is going to be given by 18.7 meters per second times cosine of 55 degrees. So put that in your calculator. 18.7 cosine 55 is going to be equal to 10.72587 meters per second. Keep it to more decimal places because we're going to be using this value later on in calculations. This y value of the velocity is going to be 18.7 times sine of 55 degrees. And if we put that in the calculator, we're going to get a value of 15.318114 meters per second. Okay. Just some other things to note. This point right here, the initial y height is equal to 0 meters, and the initial x height is equal to 0 meters. This is because of the statement ground level up here in the question. If it's launched from the ground, it has a height of 0, and we're just going to call this 0 as well for the x and measure everything relative to the cannon. Okay, what are we required to find? We're required to find the horizontal distance x and analysis. Well, we're going to determine the initial values. Great, we've determined all the initial values. Determine the time using the y components. The reason I'm going to go with this direction here or going with finding time is because the question's asking for x. It's probably not going to give us enough information in order to just solve for x really, really easily. So what I'm going to do is I'm going to look towards all the y values first, and then calculate the time, and then determine the x values here. Because the last thing we got to do is find that horizontal distance, and I missed a bracket. There you go. So let's solve this question now. So looking at the y components first. Well, I'm given a final y height. So that's immediately signaling in my head that I should be using the equation y is equal to y0 plus v0y times t minus g over 2 t squared. That's because the acceleration in the y direction is negative g. So let's start plugging in some values here. The y is equal to 11.0 meters. This initial y value is 0. v0y, well, we calculate that as being 15.31814. We don't know the time. That's what we're actually going to be solving for. Minus this 9.8 meters per second squared divided by 2 times t squared. We're looking for t, but we have a quadratic, so we need to be using the quadratic equation in order to solve this problem. Let's rewrite this so it's in the standard form of quadratic. So the first thing I'm going to do, 9.8 divided by 2 is 4.9. So I'll bring that over here, negative 4.9 multiplied by t squared plus there's 15.31814 times t, and then this 11 is going to become a negative when I bring it over to the other side, 11.0, and this is all going to be equal to 0. This matches the quadratic formula, or the quadratic standard form. In this situation, we have A is that 4.9, B is that 15.31814, and C is that negative 11. So let's start using the quadratic equation here. Reminder, t is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay. Let's start putting in our values here. T is equal to, well, negative b is going to be negative 15.31814 plus or minus the square root, well, b squared is going to be 15.31814 squared minus 4 times a is negative 4.9 times c is negative 11.0, all divided by 2 times negative 4.9. So let's start solving this right now. I'm going to rewrite this as minus 15.31814 plus or minus, I'm going to calculate this value right here. So it's going to be 15.3131814 squared minus 4 times minus 4.9 times minus 11. That's going to give us a value of 19.0454, but that's under the square root. So I'm going to take the square root of this answer, and that's going to give me a value of 4.364. 4.364 and 1. And that's going to be all divided by 2 times negative 4.9. Well, 2 times negative 4.9 is negative 9.8. This is going to split us into two values for this time, okay? We're going to have to interpret what that time means, okay? So let's do the first calculation. I'll go T1 is going to be equal to negative 15.31814. I'm going to use the plus first. Plus, negative 15.31814 plus 4.3641 divided by negative 9.8. That's going to be 1.11776 seconds. Okay? What's the other value for time? Well, it's going to be using this minus sign down here. So we have negative 15.31814 minus 4.3641 divided by negative 9.8. That's going to give us a value of 2.008 seconds. Now, if we take a look up here, this makes sense to get two values. There's going to be 2 points along this trajectory where this t-shirt is at 11 meters. On its way up, it's going to cross a point that's 11 meters above the ground, and on the way down, it's going to cross a point that's 11 meters above the ground. So this value right here, the time is 2.008, is going to tell us when it is at that 11.0 meters above the ground, which is going to tell us how far away in the x direction it is. So this is the value that we want to use in any calculations. So let's jump up here to the x components. Well, we're looking for the horizontal distance, so we should be using the equation x is equal to x0 plus v0 xt, and there's some acceleration stuff over here, but remember the acceleration values in projectile motion are 0. So let's rewrite this. X is equal to, well, the initial x position is 0 meters. So this is going to go to 0 plus 10.72587 meters per second. That's the initial x velocity multiplied by that 2.008 seconds. So if we put that right in our calculator, times 10.72587, we're going to get an x position of equal to 21.54 meters. That's our final answer right here, but we're not done yet. We need to take into account significant figures. The initial given value of the velocity had 3 sig figs. The y had 3 sig figs. So 3 sig figs, 3 sig figs. So the final x position should have 3 sig figs as well. So let's round that up. That's going to be x is equal to 21.5 meters. So what do we need for our statement? Our statement should say something like this. The cannon should be placed 21.5 meters away horizontally. And that's everything that you need in order to solve this problem. If you have any questions or you want to say something, leave a comment in the comment section below. Like the video and subscribe, please. Thank you very much.